So, electrostatic force or potential energy between two atoms that we have seen in last class, that basically holds the atoms in solids. So, that electrostatic force if as a function of r, the distance between two atoms that we have written in last class, a by r to the power m minus b by r to the power n, where n is greater than m, and corresponding potential energy u as a function of r, a by r to the power m dash, this minus here plus b by r to the power n dash. In last class the dash was missing. So, basically m dash equal to m minus 1 and n dash equal to n minus 1. So, this now this a small a, b, m dash, n dash another constants, characteristic constant of atoms. So, this the potential energy, it will be minimum for a particular value of r equal to r0, that we have seen in last class, and that has come out a b by a n dash by m dash. So, the dash was missing in last class. So, one has to put dash to the power 1 by n dash minus m dash. So, this the equilibrium distance between atoms in a solid, and that equilibrium distance depends on the atoms a, b, m dash, n dash. These are the constant characteristic constants for atom, and we have plotted earlier. I think I have to so y axis is potential energy and x axis is basically r. So, if you think that one atom is here and another atom moving towards this atom. So, basically r is changing, and because of change of r, the potential energy will change. So, this change we have seen this, it's like this. So, for a particular value of r, so this r0, the potential energy is minimum. So, when atoms are in a solid, the interatomic distance will be r0 so that the energy of the system will be minimum. So, that nature prefers. So, always nature try to minimize the energy of a system. So, thus the atoms in a crystal or solid they will arrange keeping the equilibrium distance. So, next atom will come here, next will come here. So, this way, so atom will be placed in solid or solid forms, arranging the atom itself in the solid this way. So, this other side also say they will sit like this. Okay. So, similar way, so one can say arrangement of atoms will continue. Like this. Okay, so atoms will arrange in solid keeping their interatomic distance equilibrium distance are 0. Now, this is 2-dimensional picture. So, in other way also, other side also, other direction. So, atom will follow the same way. Okay. So, one can get the 3-dimensional arrangement of atoms in solid. So, if you see this picture, so here one can identify a pattern unit, pattern unit say like this, and the same the structure can be produced just repetition of this unit. So, that is why it is we tell this call it is pattern unit. So, atoms are arranged orderly in solids and then it will have a pattern unit. Then the repetition of the pattern units will give the same structure of that solid. So, if I pick up, if I know the pattern unit of a crystal structure, and now if I repeat this pattern unit, so then we can get the same structure of that crystal. So, pattern unit say now I know the pattern unit of this crystal structure is this. Okay. So, now just repeat this one, just repeat this one, repeat this one, repeat this one in all direction, right. So, then you will get the same structure as just we have put the atoms following the equilibrium distance minimum energy. So, whatever the structure we got, the same structure we will get if we repeat the unit pattern in space. Okay. So, this way these atoms are arranged in a solid, because this ordered structure is preferable by nature because of minimum potential energy, but it is not the always case. Sometimes this it violates because of the external condition, external environmental condition like temperature, pressure, say rate of cooling or heating, rate of cooling, or heating during formation of the crystal. So, these external parameters, external environment affect the crystal structure. So, thus atoms assembled and form a solid. So, mainly two types of solid, structure wise two types of solids are found. One is crystalline structure of solid, one is crystalline structure or crystalline solid, another is amorphous solid, So, in nature whatever these solids we found, most of them are under this group. Crystalline solid, but there are some materials which are amorphous, say this, for example, this glass is a amorphous solid. So, what is amorphous and what is crystalline solid? Let us define. So, crystalline solid is basically atoms are arranged orderly in the solid, so that then it is crystalline solid. When atoms are not arranged orderly, they are arranged randomly in the solid, then it will be called the amorphous solid. So, basically here atoms are arranged randomly in solid. Okay. So, this crystalline solid, again it is two types. Crystalline solids, again it is two types. One is single crystalline solid, and another is polycrystalline solid. polycrystalline solid. Okay. So, both are crystalline, that means atoms are arranged orderly in the solid. So, difference between these two are basically it's single crystalline is a long range ordering of the atoms in the solid, and this is polycrystalline, this is basically short range ordering of the atoms in the solid. So, what is that? So, when throughout, if you take a piece of material, take a piece of material, say take a piece of material, okay. Now, in this material, in this piece of material, if atoms are arranged, in same manner, atoms are arranged orderly in same manner throughout the material, then it is called single crystalline solid. But during the arrangement of the atoms in the solid, if sometimes interruptions are there, if arrangements are interrupted, so then it will not be single crystalline, it is called polycrystalline. So, basically if I just atoms are arranging like this throughout the material, so it is single crystalline. But what happens during this arrangement, if after some distance, if it is interrupted, means it is not continuing in same way, so then so it is just here that interruption is there, because of interruption. So, this now it is again ordered, arrangement is ordered, but what is the difference you can see. Here say okay. So the same arrangement are there, but there is interruption at some places, okay. So it is not continuing in same way. So then this and this, their atomic arrangement are same, but just we can see this is as if here the just orientation is changed, slightly orientation is changed, okay. So in this, so this region same way it is arranged, in this region also same way it is arranged, but just change of orientation at this boundary. So this region they are called basically grain or crystallite, crystallite or grain, this also crystallite or grain, and between these two grains there is a boundary, so this called grain boundary. This is called grain boundary. So basically this in polycrystalline solid we will find many grains are arranged with grain boundaries, and the same solid can be single crystalline when this interruption is not there. So, there will not be any grain boundary. So, this grain and this other grain they will have the same orientation. So, as if they are continuing the arrangement in same way. Okay. So single crystalline, so it's say the arrangement of the atoms in a large region, and polycrystalline it's basically arrangement of the atoms orderly in a small region. Okay. So that's why it's I told that the single crystal is long range order and the polycrystalline is basically short range order of the atoms. Okay. So we will concentrate our discussion on this crystalline solid and basically the single crystalline solid. So if we take a piece of material and want to know the structure of that material, that is our interest. We want to learn the structure of that material, means how atoms are arranged in that material, that we want to find out, we want to learn. So a piece of material crystalline material, single crystalline material. Okay. So means what we know, that atoms or a group of atoms are arranged orderly in this piece of material. So that is known, that we defined as a single crystalline solid. So secondly what we want to find out, that or already we have discussed that in this material one can find out the pattern unit. So it is single crystalline, atoms are arranged orderly, so it will have a pattern unit. So as I told, or we have seen that if we know the pattern unit of a crystal, then basically we know everything about the structure of the crystal, because pattern unit contains all informations about the crystal, and repetition of the pattern unit is basically forms the crystal structure. Forms the crystal structure, right. Form the crystal structure. So to study the crystal structure of a material, basically we will study the pattern unit of that material. So, this pattern unit of that material, that we have to find out. Now, question is how many materials exist in the universe? Answer is thousands and thousands materials exist in this world. In this classroom itself, you can see many solid materials: chair, table, window, computer, blackboard, dusters, everything a solid material. If you go just outside of this classroom, you will see car, train, bus, road, building, glass window, etc. And in dining table also we use salt, right? Salt we use. So, these all are solids, and many solids exist around us. So, now question is this pattern unit of each solid will be different, or it will be same for all materials. So, if it is different, it cannot be same for all materials, that is obvious. Now, whether for each material this pattern unit are different, or there are some limit in number of this pattern unit. So, answer is similar to the number of atoms, as we discussed earlier, that only 92 types of atoms forms all matters. Thousands and thousands, millions and millions matters exist in the world, but all are made of only 92 types of atoms. Similarly, the crystal structure of materials, they have few number of pattern unit, and using these basic pattern units, one can get all sorts of materials, solid materials, just changing the atoms or group of atoms, which will give different names of materials. So, in next class we will learn about the pattern units, how many pattern units are required to describe the structure of all materials. Thank you very much.